Now that we know the definitions and values of the trigonometric functions along with the identities that relate them, let's get some practice using these things. So what I want to look at are some examples like this, where I've given you a trigonometric function value, and then I've also given you a location where the angle is. So for instance, on the unit circle, we can think of these angles as being in the unit circle. So I've drawn us a unit circle up here for reference, and let's think about why we need to know where we are in the circle. So I know that my sine of this theta, whatever theta is positive. So that means when it hits the unit circle, the y value is going to be positive. So it's going to be somewhere in this top half of the circle. Now, if I look at the top half of the circle, I have two different places I could be. I could be over here, where the x value, or the cosine of that angle, is going to be positive. Or I could be over here, where the cosine is going to be negative. So in order to get rid of that confusion, what I'm saying is we're definitely working in this part of the circle, so we know that cosine is going to be positive. So now we've gotten rid of that confusion or that ambiguity. So we know for certain we can find all the rest of our values. So I think actually, I'm going to start with cosecant. I'm going to go out of order. Because cosecant is just 1 over sine of theta. Well, we know sine of theta. So we have 1 over 0.1. Just to make this look a little neater, because I know that 0.1 is 1/10, I'm going to write it like that. Then I'm going to flip that bottom fraction and multiply by it. So I have 1 times 10 over 1, or that's just 10. So cosecant of this theta is 10. That wasn't too bad. Now let's think about what else we can find. In order to find secant of theta, we need cosine of theta. So we can't get there yet. We also need both sine and cosine for cotangent. Same thing with tangent. So it looks like the next thing I should probably find is cosine. But thankfully we have an identity that'll help us there. It's one of our Pythagorean identities. It tells us that if we have the sine of theta, we square it and add the square of the cosine of theta, that's going to be equal to 1. So I know this value, I don't know this value, but it's what I want to find. So that's a good thing. So this would be 0.1 squared plus cosine squared equals 1. Now 0.1 squared, I'm taking 1/10 and multiplying it by 1/10. So that's actually going to be 1/100th, or 0.01. So when I move this then to the other side, I get that cosine of theta is equal to 0.99. Now, this is why I needed to know where I was, because if I didn't know that I was in this first piece of my unit circle, the first quadrant, then I could say, well, cosine of theta could be the positive square root of 0.99, or cosine of theta could be the negative square root of 0.99. But we've determined that our x values here are positive, which tells me that my cosine value is positive. So we're going to take the positive square root of 0.99. So now that we know sine and cosine, we can find all of the rest of these. So for tangent, we just put those in. So there's our tangent for this angle. Secant is just 1 over the square root of 0.99. And then cotangent is just the opposite, or the reciprocal, I should say, of tangent. So notice that by knowing these definitions and this one identity, I was able to take one trig identity. Once I knew my location in the circle, I was able to find the rest. So now let's work on this example. Notice I've switched up where we are. We're down here now. So cosine is positive because our x's here are positive, which is given. But our sine is going to be negative since our y values there are negative. Just so I don't forget, I'm going to put a negative there, just so I make sure I remember that when it comes time. Well, I know cosine, so secant is going to be easy. Just 1 over cosine of theta, or 1 over 3/4. But again, I can take the reciprocal of the bottom fraction and multiply that times the top, so I get 4/3. Now, to find cotangent, I'm going to need sine also. To find cosecant, I'm going to need sine. To find tangent, I'm going to need sine. So I guess that my next best bet should probably be finding sine. But we can use this exact same identity, right? We know cosine now, we want to find sine, so we know how they're related. So I get sine squared of theta plus, I want to square my cosine value and add them. They become 1. So, when I square this, I get 9 over 16. And then the 1, I'm going to write as 16 over 16, just because that means I'll then have a common denominator. It'll make my life easier when I start subtracting. Or when I move this 9/16 to this side, which I'm going to do right now. So I get 7 over the square root of 16. And this was again where we needed to know that sine is definitely negative where we are in the circle. So sine of theta is going to be the negative square root of 7 over 16. But conveniently enough, we know that the square root of 7 over 16 is the same as the square root of 7 over the square root of 16, which we know. So we end up with the negative square root of 7 over 4. So now it's just a matter of plugging those in where they need to go. So 1 over sine of theta is going to be 1 over negative square root of 7 over 4. That flips the bottom fraction, so I get negative 4 over the square root of 7. Tangent will be negative square root of 7 over 4 divided by 3/4. So that bottom fraction is going to flip and multiply times the top, so the 4's will cancel. I end up with negative square root of 7 over 3. And then down here, I end up with 3/4 over negative square root of 7/4. So again, the bottom fraction flips. When I multiply that times the top, the 4's will cancel. I get negative 3 over the square root of 7. So again, we were able to find all of our different pieces using definitions and one Pythagorean identity. So this time I want to start with tangent of theta. And I want to say that we're going to be between pi over 2 and pi for our angle, which puts us here. So that means that my sine values, my y values are positive, but my cosine values are negative. So I'm going to make a note to myself to remind myself my cosine values are negative. Then I have tangent of theta. Okay, so there's what we want to find. Now there are two different ways that we can start this, and I'll do one and then the other so you can see it both ways. So, first of all, I have a second Pythagorean identity that happens when I take the one we were using before and divide through by cosine squared. we get 1 plus tangent squared of theta is equal to secant squared of theta. But I know tangent, it's -2, so I can put that in there. And I'll get secant squared. So this is 1 plus 4, so I get 5 for secant squared. Now, we need to know whether we want to take the positive square root or the negative square root in this case. So if we look back here, we know that secant is 1 over cosine of theta. Well, cosine was negative, so if we take 1 over that, this is also going to be negative. So if we take the square root, we want to take the -1, so we get that secant of theta is equal to the negative square root of 5. So there, I got my first piece. But now, secant is 1 over cosine. So this is the same as 1 over cosine. So I want to multiply both sides by cosine. I can divide by the negative square root of 5. So what I get is that cosine of theta is equal to -1 over the square root of 5. So there's cosine. So now I'm theoretically back in the same position I was over here, except I have a little bit more information. I also have tangent. So, in order to find any of these three, I need sine. So let's go ahead and find sine. Now again, there are two different ways to do it. I could do exactly what I did here and use the Pythagorean identity, but I also have a unique way since I already know my tangent. So I know that tangent of theta, which is equal to -2, is sine of theta over cosine of theta. Well, now that I know cosine of theta, it shouldn't be too hard to find sine of theta using this method. And this is because I already knew tangent. So if I multiply on both sides by -1 over the square root of 5, I have negative times a negative, so I get a positive, which is what we were expecting for sine. Remember, we said sine was positive here. And we get 2 over the square root of 5. So there's our sine value. Again, if you went through and used this identity, the sine squared plus cosine squared identity, that would get you the exact same thing. So now it shouldn't be too hard to find tangent. So that will be 2 over the square root of 5 over -1 over the square root of 5. We're going to flip that bottom fraction, multiply times the top fraction, so we'll get -2. Which we already had. I wrote that down twice. Anyway, you get the idea. We already had that. This will be 1 over sine of theta, 1 over 2 over the square root of 5. So I flip that bottom fraction, multiply times the 1. So it's the square root of 5 over 2. And then cotangent is going to be cosine theta over sine of theta. So this was -1 over root 5 over 2 over root 5. So flip that bottom fraction, multiply times the top, I get -1/2, which we'll notice is the reciprocal of tangent, which we found again. It's a good way to check to make sure we got the right sine and cosine values since we're using those to find the rest of these for the most part. Okay, now I said there was a second way to do this problem. So let's investigate that. So a second thing we know besides this identity, a second identity we know for tangent, is that tangent is equal to sine over cosine. Now remember when we started, all we had was tangent. So I know that sine of theta over cosine of theta is going to be -2. I don't know sine yet, I don't know cosine yet, because we're starting over. But what I do know is that I can write this as -2/1. This is where we need to be really careful, because it's tempting to say, oh, well, I have a fraction set equal to a fraction, so the tops must be equal and the bottoms must be equal. But that's not always true for fractions, because we can reduce fractions and not change their value, but change what numbers are on top and bottom. So we need to be really careful. We can't just assume that cosine is 1 and sine is -2, especially because -2 isn't even a value that sine can take. So we can't do that. But what we can do is we can actually cross multiply here. So I have sine of theta times 1 is equal to -2 times cosine of theta. Well, that's handy, because the other thing I know about sine and cosine is the Pythagorean identity. But now I know how to write sine in terms of cosine. So if I put this in for my sine value, I have all of this in terms of cosine. I should be able to solve for it. So I need to square both pieces, so I get 4 times cosine squared plus another cosine squared. So really what I get is 5 cosine squared is equal to 1. So I can divide by 5. And remember, way back when we judged based on where we were in the circle that cosine would be negative, so we're going to take the negative square root. And again, I can take the square root of 1 over the square root of 5, but the square root of 1 is itself. So we get the exact same cosine value we got doing it the other way. The other thing we can do is now we can look back at this equation. I know that cosine is equal to -1 over the square root of 5, and sine is -2 times that. Well, a negative times a negative is a positive, so I get 2 over the square root of 5. So using this method, from tangent, I then found sine and cosine. Now I'd very easily be able to find the rest of these values using the same method. So these two would give us the same answers if we kept going. Okay. One last example. Let's say that cosecant of theta is equal to -2. And this time we're going to be between pi and 3 pi over 2. So we're going to be down here. Notice here that sine is negative, cosine is also negative. Okay, so we do have a Pythagorean identity involving cosecant. It would be 1 plus cotangent squared of theta is equal to cosecant squared of theta. Theoretically, we could use this, we could find cotangent, then use a similar method to what we did over here, except with cosine over sine, to find sine and cosine. That's an acceptable way to do this. I think it's going to be a lot more work, but it's absolutely acceptable. I'm not going to go through and do it that way. All the work would look very similar to this. What we can do is we know that cosecant is equal to -2, but we also know that that's just 1 over the sine of theta. So if I multiply on both sides by sine theta, I get -2 sine theta is equal to 1. So I divide by -2. Sine theta is -1/2. now I can go back to my original Pythagorean identity. So sine squared plus cosine squared is equal to 1. So negative 1/2 squared will be 1/4. I'm going to write 1 as 4 over 4. Subtract this from both sides. So cosine of theta squared is going to be 3/4. And then I'm expecting cosine to be negative, so I need to take the negative square root. And again, I can take the square root of 3 over the square root of 4. I know the square root of 4, so I can take it. So we get negative square root of 3 over 2. Now it's just a matter of plugging things in. Tangent is sine over cosine. So we get negative 1/2 over negative square root of 3 over 2. The negatives will cancel. I'm going to flip that bottom fraction, multiply times the top. So the 2's will cancel. I end up with 1 over the square root of 3. Secant of theta is 1 over cosine of theta. That's going to be 1 over negative square root of 3 over 2. I'm going to flip that bottom fraction, multiply by 1. So negative 2 over the square root of 3. And last but not least, cotangent is cosine over sine. So I have negative square root of 3 over 2 over negative 1/2. Flip the bottom fraction, multiply. I'll end up with the square root of 3 over 1, which is just the square root of 3. So no matter which value I give you, as long as you're given one value and a location in the circle, we can find all the other trig function values.